Martin, what is magnetism?
Magnetism is always associated with electricity and electric currents. And you might say, well, I've got a magnet here and there's no electricity, but there is. I'll explain how in a moment. So if you put a compass, say, that normally points north, the Earth's magnetic field, if you put it near a cable that's carrying a current, the compass will deflect because there's a magnetic field around the electric current. And that's the way it works. So a magnet itself uses the electrons in the atoms. So most materials, the electrons spinning around the center of the atom can't be aligned for various reasons. So the effect you get from those electrons spinning round the atom, so remember, an electron is a negative charge, it's spinning round the atom. It creates a magnetic field because it's an electric current effectively spinning around the center of the atom. So most materials, you can't align the atoms in materials. They're all higgledy-piggledy and they cancel each other out. But iron is quite different. If you wrap an electric cable, say, around an iron rod and put a current through it, the iron will become magnetized. Because what happens is that the atoms all align in the same way. So, each individual atom is like a little magnet. It's got the electrons spinning around the center of the atom. And that orbiting electron creates a little magnet. And there are obviously billions of them in any piece of iron. So when you put a current in a cable that's wrapped around a piece of iron, all the atoms will tend to align. I mean, they don't all align, but the stronger the current, the more they will align. And what's more, that alignment may well stay. They're not particularly bothered which way they're directed. So that's why a magnet, even though you can't see the electric current in terms of the electrons spinning around the atoms, it is still the effect of electric currents. So each individual atom is aligned in a particular way. The electron going round the atom creates the magnetic field, and all the norths or all the souths align in the same way. And so the overall effect is that you get a magnet. And it stays there. You can demagnetize them by just, any number of means. But typically a piece of iron, once it's magnetized, will stay magnetized. And in fact, even the end, they even sell screwdrivers with magnetized ends on them, so that you don't drop the screw. The reason that it doesn't happen with almost all other materials, it can happen to a small extent, is that you cannot align the atoms in the material. If you can't align them, then the magnetic field from each particular atom is just this way, that way, and they all cancel each other out. Now, the strongest magnet you can get is made out of something called neodymium, and it is so strong that it can support 1,000 times its own weight. And they're fairly expensive magnets, but they are the strongest magnets. So what is that telling you? It's telling you that all the atoms in neodymium are aligned in pretty much exactly the same way and giving a very, very strong collective magnetic field, because the atoms are aligned, so the electrons are spinning round in the same way, creating lots of little north and south poles and creates a very strong magnet. The use of magnets, well, I guess you know, electric motors. There'd be no electric motors without magnets. And the MRI scanners, magnetic resonance imaging, uses very strong magnetic fields to essentially probe inside the human body. And, you know, they're everywhere, fasteners and so on. So, you know, the phenomenon of magnetism is quite strange, really. It's just lots of little atoms in typically something like iron that all align in the same way and produce a net effect that is basically a north and a south pole on the piece of iron or whatever it is you're looking at. And magnetism is part of the way we look at electromagnetic radiation and a whole pile of things. So anyway, I hope that explains to you what magnetism is. It's, in terms of materials, it's when all the electrons are kind of spinning in the same way in atoms and they all align in the same way and give a net magnetic field.